Welcome to More Than a Refresh. This is a slightly different episode series that we have, as we are a media sponsor for an observability conference. This is the Open Source Observability Day interviews, and today our guest is Costa. Costa, could you say your last name, please?
Yes, it's Tsaousis. Hi guys, hello.
Okay.
Tsaousis.
Costa is coming from us from Athens, Greece. I am in Bellingham, Washington. And of course, as usual, our great producer, Lindsay, is in Astoria, Queens. Do me a favor, Costa, introduce yourself and give us a little bit about your background.
Okay guys, so I am the founder of Netdata, the open source observability solution. I have been a C-level executive my whole life, since my 30s. I am 56 at this time. So Netdata, I created Netdata mainly it was born out of a need. So I was facing issues. I tried all observability solutions, didn't work. And after spending a lot of time and effort in observability, I decided that there is something fundamentally wrong about how observability solutions are. And I started as an experiment. So I said, okay, let's see why they did it like that, why there is no high fidelity, why you have to configure everything by hand, why this, why that. And after some time, the data was born. It was a weekend project, nights, weekends, and the likes. I released it on Github, and it went viral. It's probably one of the fastest growing projects on GitHub. So the first week that I released it, it got 10,000 GitHub stars. Today it has 80,000 or something like that. So then it was the user's love. It's the fun part of the open source world. The user's love made the difference, and I decided at some point to give up everything I do and dedicate myself to it. So today there's a company that supports the project. There are customers, investors, a big team that works on the data. But it all started, let's say, not in a garage, at my living room.
So, like the good old days of HP in the shed kind of thing. So it's interesting to me that you said why, and you really touched a nerve for open source people in general. You said, well, why does everything have to be configured by hand? Why is everything so complicated? And I've been in this open source world. I'm a little younger than you, not much. I'm going to be 52. And I've been doing this open source thing since I was like 19. And when I was 19, it was fun to tinker. It was fun to compile the Linux kernel and all those types of things. But now, I just want the shit to work, right? I got better things to do. And, I'm curious. One of the things that engineers aren't very good at is recognizing the user interfaces. They're more about, correctness, which is good, obviously. And does it return the correct result? Does it do what I intended versus does it do what I intended well? And so anything, especially in observability, I think it would be important because oftentimes, and correct me if I'm wrong, but oftentimes the people looking at these dashboards, right, in these reports, they're not necessarily engineers.
They are engineers, mostly they are engineers. Look, it's a strange world. Observability for every person out there is a different thing. What I have understood as an engineer, I have been an engineer since my 17. So what I have understood as an engineer, if you don't measure something, if you don't see it working right, even if you wrote the software yourself, guess what? It won't work right. This is true even today. So today I write code still, and I need to see the numbers. Otherwise, I'm not sure that it will. I hope that it works, but it's not sure that it works. So look now what happened. The key problem with observability is a crucial part. for an infrastructure, especially if you run operations. It's crucial. Now, the key part with observability is that the design of observability is that makes observability complex. The design. That was the first thing that I found out. That, come on, this design is not good enough for you to have clarity to understand what your infrastructure is doing. What says this design? This says that, okay, you have observability data, you collect them here and there and whatever, or across your infrastructure. You put them in some databases. So you gather everything together and put it here in databases. This is true for metrics, for logs, for traces, for whatever. Put them in the databases. And then once you have them in the databases, then have some algorithms to actually extract alerts or dashboards or whatever. But the key thing is bring it all here. Now, mainly because this design, let's say, they bring it all here, centralize the data, mainly because you do this, then you start thinking, okay, do I really need this metric? Do I really need these logs? Do I really need that or that or that? You start cherry-picking information. And then another thing happens, mainly because you have to maintain the central databases. The central databases cost money to run, and also they require maintenance from you. So eventually you end up trying to minimize the cost and maintain the maintenance they need. So you start filtering metrics and lowering data collection frequency. When you do this, you end up with an observability solution that is pretty good to tell you what happens overall in your infrastructure. Okay, you have a problem there, but that's it. After that, you are alone. How do you solve the problem? Oh, go figure. Open a console, SSH there, do something. You're going to figure it out, we are sure. But observability cannot help you. What I wanted, and this has a series of problems, mainly because observability tools do not work how I started in the data. The problem that I had is that a hosting provider, a cloud provider, was doing maintenance work on the hosts of the cloud VMs, and they were freezing the VMs for tiny amounts of time, but thousands of them in an hour. If you face a situation like this, you see that your infrastructure goes in slow motion like this. It's not smooth, does not run. So when I realized this, I didn't know that this was the problem. I was trying to figure out what was the problem. And I built Netdata to work in a bit. So what does this mean? What is a bit? This means that it collects data every second. If it misses a second, for whatever reason, it doesn't matter what. If it misses a second, it's a gap on the chat, a gap. So you can see it. For some reason, it missed an iteration. This is important. This is how I figured out what was happening with my infrastructure back then, because when the problem was there, all my charts were cut all the time. So trying to figure out what happens and why this is there, I realized that it's the hosting provider that does it. It's not my application. It's not my Linux kernel or whatever I have, my Linux installation. It's the hosting provider freezes the VM. Now, in most observability solutions today, take anyone, it doesn't matter, the biggest names. What they do is that they have random samples here and there, and then they connect the dots. They just connect the dots. They say, okay, I got a sample there, I got a sample there. Let's connect them. And this is what you see. If a sample is missing, nothing happens in their observability. Nothing. Right? They just connect to the next dot. You get it?
Well, and I think that they do that obfuscation on purpose because it gives an artificial showing or display of performance. Speaking from my own background, we once had a client that, you may not know, but we're pretty big in the Postgres space. Mm-hmm. We had a client that called us and said, look, we need you to optimize our Postgres installation, our Postgres infrastructure. There's something going on here. And they had observability. but it was set to every 10 minutes. Every 10 minutes it would pull, right? And then what happened is that once an hour, the system would just be slammed, and they had no idea why. And it took an act of a C-level exec to allow us to make the observability down to a minute, just like you do now. Now, back then, a minute was a big deal. Right? This was 15 years ago. What we found was there was a moment every hour where connections and transactions would spike. And what it was is they had acquired a firm like 6 months before or something and had just got this infrastructure. They didn't really know how the firm worked. They knew what the product was. And what it was is there were thousands of devices out in the field that would do a check-in all at once. But it took us forever to figure it out because we didn't have the observability talking about.
Yes, exactly. So Netdata today, for example, is per second. As a standard for every metric, everything is per second. And also we have data collections to visualization latency of 1 second too. So you hit enter on your keyboard to make a change. 1 second later, it's on your dashboard. Okay, so you see it. Actually, the difference, what people say is that with Netdata, they can feel the pulse of the infrastructure. They can see it. They can see it working in the micro world.
The heartbeat.
So, but continue with the previous thing. Now, once you solve the scalability, Netdata has solved the scalability problem. We don't centralize the data. We keep the data at the edge. So the difference in mentality is that instead of centralizing the data, we distribute the code. So you have 1,000 servers out there. We have 1,000 installations of our code. This is the agent. This is the normal thing that all observability solutions call an agent. The difference in the data is that this agent is everything. It's a whole observability pipeline in a box. It's everything there. So it has database, it has alert engine, notification engine, machine learning. So everything is at the edge. Now, once you solve this problem and you have the ability to collect any metric, we just auto detect what this server is doing. Oh, it runs a Postgres, it runs a DNS server, it runs this web server, it runs this and this and this and this. And we scan everything and we collect everything, every metric that we can find. Why we do this? Because it doesn't cost. It's at the edge. It's inside the server. It's a small data set. Now, once you do this, then you have the next problem. Okay, how do we visualize and alert on all this data? Okay, we have them. It's in our database. Now what? So what we did there is that we built a fully automated dashboarding, and we also provide alert templates. So what we say in Netdata when we build Netdata is, hey, you know what? On every Nginx instance that you're going to find, attach these alerts. On every Postgres, these alerts. On every network interface, these alerts. On every storage device, the block device, this. On every mount point, this. So we go on and we templatized, let's say, all of it, including visualization, so the dashboard comes by itself. You install it and boom, it comes up with a dashboard by itself. Now, once you do this, you have other challenges to solve. What are the other challenges? Okay, now people see metrics and dashboards for the first time. They didn't decide it themselves. They just installed the thing, they opened the browser, and now they have a fully functional dashboard. How do you make this dashboard extremely useful immediately on first sight? That was another challenge. Then other challenge was, okay, we have the data, we have the dashboards, we have the alerts. Now, can we use somehow machine learning to actually help us understand what is abnormal in our cases? So what we did there is that we have totally unsupervised machine learning. Guys, everything that I say so far is open source. It's free. You can use it. It's the agent. I just install it. So fully unsupervised machine learning. What does this do? it uses, it collects metrics. We collect metrics all the time, eh? The agent that you run at the edge. This agent now trains machine learning models, multiple actually, for each of your metrics, each. Now, after some time, what it can do is for every sample collected every second, it can tell you if this was an outlier or not, if this is an outlier or not. Eh? Is this an expected value or not?
So
For
let me
this,
ask you this. Well, first, let me commend you for not using the term AI, because I'm just so
no, come on.
done with the sex fest of AI.
No.
Yeah, machine learning, I understand. And that's actually, I was curious about that. Exactly what you're about to say is that, so we're collecting all this information. You've got some algorithms, machine learning, that are looking for the anomaly.
Mm-hmm.
Now, the question I have is that when you're monitoring this much information, how do you generalize what an anomaly is? How does the machine learning?
It's very simple. It's very simple. It's in layers. So look what happens. At the bottom layer, there is a single metric. Imagine that you have just a line, numbers over time of a thing. Okay? It doesn't matter what it is. Now, what you say there is based on the past. I know 2 hours of it. Eh? I have 7,000 samples of it. Okay? For 2 hours because it's per second. Okay? Can I now train a machine learning model to actually predict the value that I'm going to get? There are some metrics that this is impossible. Interrupts, hardware interrupts. What to model? These things go square all the time without any, it's something that happens in the hardware, you don't have a clue. This is full of anomalies and usually we exclude them. It's full of false positives and usually we exclude them. But if you have something that is related to something else, like the workload that you receive, then as the workload starts having periods, intense periods, low periods, relaxed periods, etc., the machine learning model learns how the metric behaves over time. It learns the patterns. Even the period, even if it is periodic like this all the time, it will learn this is periodic, it goes like this all the time. Or it will learn that at 10 o'clock in the morning, this is how it works. At 6 p.m. in the afternoon, this is how it works. At night, this is how it works. So what happens is that then the machine learning algorithm by itself and the model it had built, it has available for this metric, one metric we're talking, it's able to tell you if the sample you just collected is anomalous or not. That's a true-false. Is it anomalous, yes or no? Then what we did, this is the lowest level. Then we went a level up above. Okay, let's store this true-false, this bit. Let's store it in the database. Netdata is the only observability solution that does this. So for each sample that we have, we store there if the anomaly, if the machine learning, at the time it was collected, thought that this is anomalous or not. This allows you now to see a day of data and actually calculate an anomaly rate. Say, okay, it's 10% anomalous over the day. Okay? Now, if you go at another level above, we created in Netdata a scoring engine. What is a scoring engine? We know query engines. They get the metrics, we filter some metrics, and they give you a time series that you can present. That's a query engine. What's a scoring engine? It goes through all of the metrics, everything that it has, and scores them, orders them according to an algorithm, one of which is machine learning anomaly detection. So this means that for any time frame, you can go and ask Netdata, tell me which metrics are the most anomalous ones. So you highlight a spike on a chart that you have a problem, a dive on sales or whatever, and you ask the system to tell you during that time frame which metrics across the board, across everything, across your entire infrastructure were most anomalous. And then you find correlations. At this moment, you find correlations that you didn't expect. For most observability solutions, troubleshooting is speculation. You see a problem, you start speculating, oh, let's assume it's the disk. Let's validate or drop this assumption. Oh, it's the network. Let's validate or drop this assumption. For Netdata, what we say is the other way around. So highlight your problem that you know is problematic and let the system tell you what correlates to that during that time. So Netdata will tell you that, you know what, the database was anomalous at that time. TCP research on the network, the DNS server had a lot of not found domains, for example. So the correlation is the other way around. Your aha moment is in the results.
No, I was going to say, I mean, everything you've said so far, I mean, is interesting, but the cherry on top was that correlation. So before I moved into my C-level, I was a database guy. And when you're a database guy and you're diagnosing database performance or whatever, the first thing you always check is disk. I mean, back in the day, it's always disk first because that was the slowest part of the system, right?
No.
But having the ability to actually go to a website, go to a dashboard, and say, okay, we know we have an anomaly here. Click that anomaly, and then it basically explodes out and says, well, at the time of this anomaly, you had this spike in your IOPS, or you had this spike in your network, or both, and where they correlated. I could see where that would drastically reduce diagnostic time.
No, not only that, imagine the other thing. What we realized once we built the whole thing is that anomalies happen in clusters. So anomaly, it's not one metric may be anomalous for some time and nothing. It's nothing. It's noise in the machine learning thing. But if you see attacks, if you see severe problems of some kind, something abnormal happen in your infrastructure, then what you should realize is that a lot of metrics get anomalous concurrently. And what we see today, we have a visualization where we show anomalies even across nodes, across your infrastructure, across all metrics across your infrastructure. And then you see that an anomaly on one node, you see a spike on one node, and then on another node, and then on another node, and other anomalies that are on 10 nodes concurrently. So you see a spike on the simple anomaly rate per metric, but then if you build and calculate this averages at the top of everything, you see infrastructure level anomalies, and they always happen. The big problems always happen in clusters. It's not one metric. It's a bunch. It's a lot of metrics that went anomalous at the same time. So all this, for me, it's a fundamentally different. So what we try to do is simplify the lives. Observability, as time comes, it becomes incrementally complex. A lot of technologies, a lot of things to do. It's a complex thing, and the technology is vast today. So what we're trying to do with Netdata is simplify the world. Most of our customers approach us mainly because they are, let's say, tired of the observability world, of the observability industry. It's either too expensive or too complex. Or too
there's also a lot of solutions, right? I mean, one of the problems, I think, especially with open source, is that, I used to love the variability of open source, 1,700 different Linux distributions. Mm-hmm. But at some point in your life, you have to make a determination that you actually just want to get stuff done, right? Observability, except for observability companies, is meant to be a utility to allow you to conduct business, right? Mm-hmm. So whether you're a doctor or whether you're e-commerce. So having something that is usable in its knowledge that it presents you, mm-hmm, greatly increases your ability to conduct business. So let me ask you, let's get a little philosophical here. I mean, you have this great idea. You said yourself, you've been C-suite basically all your career. And, in your garage, built it over a weekend, and you released it as open source. Mm-hmm. You knew you had some. Why open source?
Oh, wait. Netdata, this is the first thing that I have to tell you is that I am a huge fan of open source. I have been everything that I have been in my career because of open source software. So not only I believe that open source is, let's say, one of the miracles of our times. So in 100 years from now, probably they will speak about the open source movement and how it changed the world. So I am a fan of it initially, and I did this throughout my career because I had also other open source projects. I always try to contribute back. It was a thank you guys. When I decided to make a business out of open source, then things changed a bit. What changed? Open source is an amazing way for marketing. Why? Today, Netdata. Today, in Netdata, we have about 10,000 new users per day in our community. Per day, every day. Out of these 10,000 users, about 200 sign up to our SaaS per day. And out of these 200, about 10 every day decide to buy. Okay? Pay. This means that you have a vast pipeline of people that are close to your project. To tell you the business, today, our business, we have about 25,000 paid nodes. That's everything that we have done so far, 25,000 paid nodes. But the open source community, we count actually how many downloads we have. We have 1.5 million downloads a day. 1.5 million downloads every single day of the agent. Okay? Only 25,000 of them are paid. Now, do the math. Okay? It's amazing the traction that you can have, mainly because you are a popular open source project, is amazing. And even startups today struggle. They want outbound, they want this, they want, the sales teams. Today, Netdata does not have sales teams. Does not. So we have revenue, we're going well, everything works, and enterprises come to us. That's the biggest difference. Can you achieve this with something else? Can you make it? Can you make enterprises come to you and not chase them with salesmen? I think that's the biggest difference in open source world today for business. Of course, there is a struggle. How much is open source? Because, come on, there are a lot of abusers, and a lot of religious guys. For a guy in Reddit a few years ago, I was the Antichrist because I released the data as GPL v3 and not GPL v2. Whatever.
Hey, at least you release it as BSD. Okay, I mean,
yeah. Even today, we have Netdata. The core of Netdata and all the observability technology is open source, GPL. But we control as closed source the dashboard. Why? Because it's free to use the dashboard with the agent, but it's closed source. Why we want it like this? Because we want to sell at some point something. So
you gotta eat.
So you have to put a limit somewhere. You can't imagine the hate of religious people with open source, that they believe that everything should be open source and businesses should not exist in this world.
I can imagine. I mean, like I said, I've been doing this since I was 19. I was once a core member of the Linux documentation project. I was once a major contributor to PostgreSQL.org. There is a stunning amount of very smart people. I mean, a lot of these people are brilliant people, but they don't make the jump from, you got to have a paycheck. Hey, so, I mean, who do you think, I mean, you have a job. How do you think your job pays you? Right? Not everything can just be free. Right? I mean, I wish it was the 60s and it was make love, not war, but, I'd like to be able to afford my truck.
No, it's practical. What these people do not understand is that we have practical issues to solve. Simple daily issues of paying payrolls, of actually showcasing product market fit, of attracting additional funds. Because if it was in my hand, everything I would do would be open source. But you can't do it. You can't do it because you are going to run out of money, and that's simple. I can't. Do you know why? When I first released Netdata, I was looking for issues at Stack Overflow and the other. So what I did is I changed Netdata so that the question should not be there in the first place. This means today we have this 1.5 million downloads a day of an open source project. Do you know how many support tickets per week?
1,000.
2, 3, 4. That's it. And half of them is because the guy didn't read what he had to read.
I often, that's actually a great point. I often say that if our clients read the documentation, we would be out of business. But you're right. I mean,
this
what
means
you
that
did,
if you do the job right, there is no support. Why to have support? Do you have support because something is difficult, strange, you can't understand it, you can't work with it? If you make it simple, then support is not needed. We have many companies that approach us and ask for support. They pay the initial support and never ask questions.
it becomes an insurance policy.
Yeah. No.
So,
okay.
Let's talk about the conference a little bit, because I mean that's why we're talking today. Why is it important? And I run conferences, so I know the answer. This is for the audience.
Mm-hmm.
Why is it important for conferences like OSOD to share knowledge? Because I mean your competitors go to this conference, so why is this important?
I think that this is a great opportunity. The first thing is that all information is available online. But these events help people gather together and exchange some ideas and talk to each other about specific subjects. So generally, I like them. So I think that they are useful. Also, a lot of companies see these conferences as a way to forcibly educate their employees. So they send them there, go there, learn. This is also a big problem. What most companies realize that the operations, the infrastructure that they have actually reflects the skills of their engineers. This is true for all observability solutions too, except Netdata, because Netdata is out of the box. So we build Netdata to be what it is. It's not you to build. You can customize it a bit, but it's out of the box. For most other observability solutions, the observability you get reflects the skills of your engineers. So if you got good engineers, good observability. Bad engineers, bad observability. Simply. So you need them trained. You need them to open their minds and see more. And this is like a seminar, I think, for many companies. So I had a lot of engineers in my life, and I was always looking for which events were very nice for them to attend, and I wanted them to attend. That was crucial because they it opens their minds.
All right, last two questions, so that we keep it somewhere close to 30 minutes.
Yes. Okay.
All right, last two questions. First question is, this whole episode, all I see, and people who have listened to my other episodes will know that I'm going to love this. I love trouble.
Mm-hmm.
Talk to me about I love trouble.
Okay. So I love trouble means that we are dealing with trouble. So in Netdata, we are full of innovations all over the place, as I described. From machine learning to the database storage, we have half a byte per sample on disk. Half a byte per sample on disk. So we innovate all over the place, from alerts to visualization to charts to everywhere. So this is a need for us to solve the biggest problem of all. Simplify observability, make it easily. So we believe that people should monitor their systems. As an engineer, I want to know always the numbers, the figures, how it works. So this is very important, and people don't do it today. We see many companies and very large enterprises that have a joke for observability. It's nothing. Like you said, they had 15 minutes or something every 15 minutes. So for us, so this is how I think, and I believe how Netdata thinks. We love trouble because we want to solve them. We want to give you insights to solve the problem. So at the end of the day, you love trouble.
Fair enough. And what are you speaking about at the conference?
Oh, I am speaking about all this journey and the challenges of building Netdata. How we managed to have this scalability, how we made we built a distributed database, how we built machine learning, what we did about the whole philosophy of distributing the code instead of centralizing the data. What changes? This is a different thing. It's harder for us. It's simpler for the user. It's a lot harder for us that we develop it. So all these challenges and the journey that we had, I just give a brief of what we did there, how we innovate, what were the struggles. And it was fun, to tell you the truth, for my part. I loved it.
All right, fair enough. Well, this has been more than a refresh and the Open Source Observability Day interviews. Our guest today was Costa. I'll let you say your last name again.
Tsaousis.
Netdata, which is open source. Grab it off of GitHub, sign up, enjoy it. Thanks, everybody.
Thank you very much. Bye.